Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the Association of the United States Army's annual conference and trade show here in Washington, D.C., the #1 gathering of U.S. Army leaders from around the world. Our coverage here is sponsored by General Motors Defense, Bell, L3Harris, and Leonardo DRS, and we're here at the AVX L3Harris stand to talk to Lynn Morgan, who is a retired Chief Warrant Officer 4 in the United States Army. A lot of experience in everything from Cobras to Kiowas to Apaches, former Chief Test Pilot of Bell. Yep. So we can see how incestuous the helicopter world is. Certainly there are a lot of Bell refugees that are here. Matt Steenman, formerly of the United States Air Force, Viper driver, F-16 pilot, Spec Ops experience as well, who's the chief engineer from the L3Harris side of things. Gentlemen, congratulations on the bouncing baby model. Earlier at Quad A, we saw a drawing that the president of the L3Harris at the time, Luke Savoy, was talking to us a little bit about the design and the attributes you guys have. So let me ask you the obvious question, which every single person doubtless has already asked you. L3Harris, absolute platinum name when it comes to technology. A lot of folks don't know who AVX is, so tell us what the two of you are doing together and what gives people a sense of confidence you guys are going to deliver a grade A helicopter. I'll start with you, Lynn.
Okay, AVX is a design team, and it's a small company out of Benbrook, Texas. We've got a lot of current industry and retired industry, very competent, actually stellar people in the design world. And we've been looking and we've been working with the government on different programs for about 5 years. As a matter of fact, we still have ongoing running contracts for JMR and Future Vertical Lift, and we've had this design concept in play for quite a few years. And this particular model plays very well to the FARA program. FARA being Future Reconnaissance Attack Helicopter.
And Matt, let me ask you what you're bringing to it. And full disclosure, right, the fact that you guys haven't done it before doesn't mean that you can't actually win this and do a terrific job with it. So, but it's a question everybody asks. So tell us what you guys are bringing to it and some of the skill set you're bringing to this as, you know, both of you have test pilot experience.
Sure, I think L3Harris is bringing its experience as a mission solutions provider, both on the mission systems side, but also on the aircraft modification side. So we're really focused on providing the cardiovascular system of the airplane, be it the electrical system, the fuel system, and then the modular open systems architecture that we've brought forward, that, you know, to provide the Army what they want, the lack of vendor lock and the ability to upgrade in the future, meet the threat, and do that quickly and cheaply.
And you guys, obviously, the Greenville business does some extraordinary mission integration, whether it's on rivet joints or other high-end platforms. So, Lynn, tell us a little bit about the configuration. Anybody who knows the coaxial rotor, we were talking about Kamov, right? Most traditionally associated with the legendary Russian aircraft maker. They did those first on the Hormone, the naval helicopter, but also then later on the Havoc. Talk to us about this configuration, because nobody also has had ducted fans on the side of the airplane. I know the X3, the Airbus product a couple of years ago had that. Talk to us about this configuration and why you guys think it's the right one for FARA.
We think it's the right combination because the requirement was to have a small package that could do a lot. We also had to have speed and range. We started looking at those requirements and how that was going to happen. In order to get a 40-foot rotor, which is a fairly small rotor design, with the capability to carry the payload and the fuel for the range, we started looking at that, and the coaxial design was the best approach. What we did on the coaxial design was use a advanced soft and plane rotor design, and since it's a coaxial, one turns one direction, the other turns the other way. This negates the need for a tail rotor, which saves us power we can put back into the rotor. Also, a coaxial system is about 10% better than a conventional helicopter in any case. So that gives us about 20 to 25% more power that we can use out of the ITEP engine. The ITEP engine is, we have a single engine in this aircraft. That allows us to utilize the most of that power. Our soft and plane rotor system, one of the beauties of it is it absorbs vibration within the rotor itself. So that vibration is not transmitted back down through the aircraft. This negates the need for advanced dampers, and so we can reduce weight, and we can reduce vibration, and we can reduce costs. It also offers us a low drag solution. This particular aircraft has a zero mass tilt, so that we're cruising in level flight, and the fans put the power straight out the back. That allows us to not have to tip the rotor like a conventional helicopter and suck down all that drag. As we accelerate, we have a wing that takes over 50% of the lift will be carried by that wing, so that takes the load off the rotor. Here again, this is all flat. The aircraft is flying flat, so we've got low drag, we can get higher speed.
And talk to us about the Gearbox Challenges, though, right? I mean, there is this, and also whether or not there's any blade slap or meshing issues. There have been a little bit of discussion on that in terms of the Boeing Sikorsky guys working through that challenge. Talk to us about how you guys are avoiding that.
We looked at the rotor design that they were looking at as far as the stiffness in the blades, and the stiffness in the blades and the increase in vibration requires more robust mast and hub. That all accounts to weight and basically loss of payload. So we looked at that and decided the wing could carry part of that load, and also that soft and plain rotor design. The way we get around the problem of meshing the blades is we started off at a safe position of the KMOV design, which is 9.7% of the rotor diameter would be the separation. We think we've got a better rotor than the KMOV, and it's going to be able to reduce that distance. We also have some other things having to do with controllability to reduce that distance. So we are trying to shrink it. Our safe spot's going to be to start at that baseline and reduce it after flight test.
Matt, let me bring you into the conversation. FARA has some very, very stringent parameters, including internal weapons carriage. Army has a whole bunch of payloads it wants to carry, whether unmanned payloads, weapons, electromagnetics. Talk to us a little bit about the performance parameters of the airplane, how much speed, how much range you guys think you can get out of this platform.
So with our current configuration, as we use our analytical tools to model that, and also the wind tunnel studies that we've done on the baseline configuration, we show ourselves easily meeting the threshold criteria and some impressive capabilities in terms of self-deployment and loiter time with a full mission loadout. You mentioned the payload capabilities. It is one of the more challenging capabilities. The Army desires a large payload capacity. And I think our design is one of the few that's going to provide the Army a true large cabin that they can iterate on in the future, not only with our baseline design, but going into the future fit any type of EW, other payloads that they would want to fit besides just weapons or ALE into the platform.
Yeah, General Francis was clear there were going to be a lot of payloads, and he was not going to get specific about what those payloads are. Lynn, do you want to give our audience kind of a quick walk around and point out the most salient features of your aircraft?
Sure, I can do that.
There you go, sir.
All right. If you're looking behind me here, you'll see that, like I said, we do have a coaxial rotor design, and it does add some height to the rotor, but that's fine. Going down, that drives into a flat pack transmission. That transmission is a reduction in weight, and it does not go down into the cabin area. So having that transmission stop at the wing allows us to have that larger cabin space. In the front, you see we got side-by-side cockpit. This particular aircraft can be flown with one pilot, two pilots, or no pilots if it's actually remotely piloted. We have a sensor suite in the front. That's currently still in development, but we're going to have an advanced sensor, and I'll let Matt go ahead and talk to that. As we're going around, I'll look at the cockpit briefly. Like I said, we are side by side. The doors are jettisonable. We have a large visibility area. The two cyclics are not interconnected. They're independent, and you transfer the controls electronically. The collectives are interlinked. The pedals are also not interlinked, and they're transferred individually as well. The cockpit suite is a full glass cockpit, and like I said, it is full fly-by-wire. Going on back, we have the engine inlets about the same area as the transmission. Down below that is the wing, and it's just a straight wing. There's no control surfaces in the wing. What we have next to that is a weapons deployment package. What that does is, to reduce drag, we're going to stow that weapon system up inside the bay. And when we have time, when we need to deploy the weapons, the doors will activate, the weapons will come out, acquire, shoot, and then go ahead and tuck them back in. The landing gear is also retractable, and with that retractable gear, that also adds to our speed. Above me here is the fan, and these fans are driven directly off of the main gearbox. And so the main gearbox, as the drive shaft goes down below the engine, splits off and turns either fan. And the fans turn as long as the rotor is turning, the fans are turning also. But you can see we've got them fairly high off the ground, and they're shrouded to protect the personnel. The way we control the fan is that's a variable pitch vane on the fan, so it can go positive and negative pitch. So you can use that for forward speed and also to slow you down on the other side. Behind that we have an elevator and a rudder. In high-speed flight, the normal controls of a tail rotor and the pitch of the rotor blade is taken place by we'll dress out the elevator so that the least amount of drag is on the fuselage itself. So pitch is controlled by the elevator and yaw is controlled by the rudder once you're up in away flight. Going underneath the bird, see the fan on the other side. We do have two fans, and at low speed, these fans can counteract. One can push and one can pull, so you can use those to turn the aircraft around the directional control as well. On the other side, we have an option because we do have this increased weapons bay in the aircraft. We don't have the transmission down below the wing. What we're seeing here is the fact that we could have an option for different payloads. One of the payloads may be personnel, so we could carry up to 6 special operations troops in this area. We could also have a major fuel cell that gives us long extended range capability.
So let me bring Matt in here. So talk to us a little bit about what's next for the program. When are you guys going to do first flight? Where are you on that? Let me start with you, Matt.
So as we look to what's coming in the program, we look forward to the Phase 2 down select and the selection there for the Army. In between now and then, we look to continue to demonstrate our MOSA approach and being the true trusted partner as a mission solutions provider and using our extensive background as a aircraft modifier to show the Army that we can provide them an affordable and easy to maintain and upgrade platform into the future. As we look towards first flight and our build out of our different test vehicles, we expect that to be in the fall of 2022.
Great. And Lynn, when do you think you're going to be flying this airplane for the first time?
We're going to probably mid-2022 we'll go into flight. We have a very compressed, aggressive flight test program, and that's in keeping with the overall FARA program to try to get this thing to the field as soon as possible.
And what are you guys doing on reliability engineering? You know, you made that's the name of the game. That's one of the things the Army wants is cost, but also a high degree of reliability. Talk to us a little bit about the engineering you guys are putting in up front to make sure that you got that low production cost, but you're also easing the burden for folks who are going to be in the field.
Sure. So I think our overall design concept from the beginning has been to design to EMD, not a conceptual prototype. So as we flow all the maintainability and reliability requirements down, we're doing that now early on in the program, so that benefits the Army rather than doing it later on after the prototype is built and fielded.
We're doing a lot of things to reduce the maintenance on the aircraft. One of it is that it's an all-electric aircraft. There is no hydraulics planned for the aircraft right now. So the rotational electromagnetic actuators produced by the Mo company are throughout the aircraft, and these are triply redundant, highly reliable, and very low maintenance as far as that goes. So this is going to be a maintenance savings, a weight savings, and a cost savings.
Lynn Morgan from AVX, Matt Steenman from L3Harris. Guys, amazing aircraft. Thanks very much for sharing with it. We appreciate it. And, you know, best of luck to you guys as you go through the process. It's going to be a nail-biter given how much really engineering work everybody has put into that. It's really, really, if you love helicopters, this is a great time to be covering the industry. Yep. Thanks very much again.
Thank you.
It's going to be fun.
It is.
Yeah, exactly. Well, I for God's sakes, I would like to get stick time in all of them at the end of the day. Will you sign my logbook if I do?
Well, sure.
I've got a little bit of husky time, so that should qualify for something.
Straight transfer, yeah.
Guys, thanks very much again. Best of luck.